Right. So far we have discussed about photovoltaic power plants. Now we will be proceeding to the discussion of fuel cells. Right. So first of all we will see what is a fuel cell. So coming to the introduction, what is a fuel first of all? So any substance which produces energy on burning in air is nothing but a fuel. Right. The process of burning the fuel in air is also called as combustion. And the fuels undergo combustion and then produce energy. But in case of fuel cell, there is no combustion involved, but the energy is going to be produced with chemical actions or chemical reactions. Fine. Make a note of this. In fuel cell, the chemical energy of the fuel is going to be converted into electrical energy through chemical actions. And the rated voltage and current of fuel cells can be increased by using number of cells either in series or parallel combinations, same as that of solar cells. So if you connect more cells in series, what happens? The voltage will be increased. If you connect different cells in parallel, the current rating can be increased. And the expected life of a fuel cell is 10,000 hours. Right? That varies based upon different types of electrolytes used, but it is in general. Okay, so here a fuel cell is an electrochemical cell that converts a source of fuel into an electric current, and it generates electricity inside a cell through reactions between a fuel and an oxidant triggered in presence of an electrolyte. Okay, in general this fuel is hydrogen and oxidant is oxygen anyways, and of course there will be an electrolyte in between. And fuel cells are different from conventional electrochemical cell batteries in that they consume reactant from an external source which must be replenished. It means in case of batteries there is storage of energy in form of chemical energy, and whenever we want we can use it for our purpose. But in case of fuel cell, we should have a fuel continuously for getting the output energy, and this continuous input fuel should also be replenished in nature, then only it becomes renewable energy source. Right. So that is the difference between battery and fuel cell. So by contrast, batteries store electrical energy chemically and hence represent a thermodynamically closed system. So the battery is a closed system, whereas fuel cell continuously needs input for producing output. Right. So here in this diagram, if you see, hydrogen input is given at the anode, and in between electrolyte membrane will be there and cathode is there. Cathode will be taking oxygen input. With the chemical reactions, it will be producing heat as well as electrons and hydrogen. Right. These electrons will be travel through the load which can consume the current. Right. So the operating principles of fuel cells were demonstrated initially in 1839 by Sir William Grove, and the first practical application of fuel cells is credited to Francis T. Bacon of Cambridge University in the year 1950. And there are several applications of fuel cells, mainly in space shuttles. So the National Aeronautics and Space Administration, that is NASA, used fuel cells in the Apollo program during the 1950s, and later in the Gemini program, which was NASA's second human space flight program. And the fuel cells were a very convenient technology for the space program because they are not going to be producing any pollution with the production of electricity and heat, and having as byproduct of water from hydrogen. All these things are what are required by the space shuttles for a spaceship, so which are being developed in case of fuel cell. So fuel cell is a convenient technology for producing power for the utilization of spaceship. And the fuel cells are used for commercial, industrial and residential primary as well as backup power generation. Primary means the main source of generation. Backup means when primary source fails to operate, we can go for it. So it can be used even as primary source as well as backup power generation in many applications. and they are useful as power sources in remote locations such as spacecraft, remote weather stations, large parks, communication centers, rural locations including research stations, and in certain military applications. So all those things you can see here. So even portable electronics are there. For laptop charging purpose you can use, where there will be a cartridge which is having hydrogen input with it, so it will be continuously given to get the electrical power as output. So even in automotive applications, in electric cars, as distributed generation, we have discussed what is distributed generation in first chapter. And of course military and aerospace, auxiliary power, backup power can also be used, and the range is from 1 watt to 1 megawatt. It is very diverse range, right? Okay, if you see here, a fuel cell car is given, shown here. Hydrogen tank will be there located at the back side, and where the electricity will be produced, and the batteries can be used for storing it so that we can use it whenever required. And hydrogen output can be coming, sorry, hydrogen, not hydrogen, water output will be there. And you can see the anode here, cathode here, in between electrolyte membrane is there, and the electrons are flowing from anode to cathode, right? And that can be used for the battery storage. And in between we can use power electronics based upon the load requirement, AC or DC. Okay, since if you can see here, electro engine, that means which is operated based on electrical input, right? So the Toyota Mirai is a mid-size hydrogen fuel cell vehicle manufactured by Toyota and represents one of the first fuel cell vehicle automobiles to be mass produced and sold commercially. So it is from the company of Toyota. Okay, so we will see the fuel cell working principle here, right? So if you see, a fuel cell is an electrochemical device in which the chemical energy of fuel is continuously converted into electric energy, and this conversion of energy takes place at constant pressure and temperature. And the main components are anode. You can see that here in the figure. This is anode, which is permanent nickel electrode considered here, and electrolyte solution will be there in between. It is potassium hydroxide, and permanent nickel electrode is used as, permeable nickel electrode is used as cathode. So it is hydrogen oxygen fuel cell. Hydrogen is continuously sent as input at anode side, and at cathode side oxygen will be sent, and with the chemical reactions occurring across the anode, electrolyte and cathode, electrons will be produced which will be flowing through the load outside, and spent oxygen will be coming out from the downside, and even spent hydrogen as well as H2O vapor will be coming out towards the anode side, downside, right? So here the fuel and the oxidant are combined in the form of ions, then in form of neutral molecules, and hydrogen acts as fuel and oxygen as oxidant, and alkaline solution of KOH as electrolyte, as we have discussed. And the fuel electrodes are of porous type, they are anode, and other porous oxidant electrode is cathode. And these electrodes are separated by a porous gas barrier called separator. All are porous because they have to be traveled from one side to the other side for chemical reactions to occur. And the anode is supplied with hydrogen gas at a certain pressure, and the cathode is supplied as oxygen as an oxidant at a certain pressure. And the electrochemical reactions are generally slow, and a catalyst is required in the electrodes to accelerate the reaction. So we of course need a catalyst for fast reaction purpose, and platinum is the best catalyst, but which is costly, and in general less expensive catalysts like nickel and silver are generally used. Okay, and these are the chemical reactions that you can check, and the overall reaction is H2 plus half O2 gives rise to H2O, right? Of course, right? This is fine. Based on stoichiometry the balancing will be done. Okay, that's it. Thank you.